Hi, I'm Gary and I'll be talking about TypeScript in this particular session. I intend to provide at least the basics so that you can get started with TypeScript and use it for development, JavaScript development, whether Angular, whether strong loop or loopback frameworks in and around the market right now. So let's get started. Let me quickly open up the terminal here and let's install TypeScript. For TypeScript to be installed, you need Node.js to be installed. And if you have not, please go to nodejs.org to install Node.js using a binary for your language, for your operating system, and install Node.js there. Node.js is an JavaScript environment that lets you run JavaScript from the server side. Now, this is something that you will be using as a development tool or an environment technically for running your TypeScript files. Let me just show you the version that of Node.js that I'm using right now. It's 10.7, which is the current version that's running. And I also have something called as Node Package Manager, which has a command of npm. And the version that I'm using out here is version 6.1. Now, TypeScript can be installed with a command called as npm install-g, which means that it's going to be available globally in your system. And I'm going to install TypeScript globally onto my system. It's going to throw out an error because I'm using Linux, and Linux technically will need a sudo for global installation. There we go, we have that. So let me quickly go ahead and get the sudo command out here, npm install-g typescript, and let me quickly put in my password as well. There we go. It should install, and in a few minutes it should actually install the latest version of TypeScript. That's what npm does, and currently the version that I have for TypeScript installs a command called as tsc onto your system, and the version that's in there is 3.0.1, which is the latest version running currently. So that was the very basic installation introduction. If you have not installed TypeScript, please go ahead and install TypeScript to get TypeScript running on your system. Every TypeScript, let me just close this terminal here, and every TypeScript file has an extension of .ts. So let's quickly go ahead and do a demo.ts, and this is going to be a TypeScript file. Anything that you write here is going to be TypeScript. There are some basic rules that is quite needed as an understanding for TypeScript. The first rule is that every basic JavaScript is a valid TypeScript. So whatever JavaScript you write, it's valid TypeScript. The second thing is the difference between JavaScript and TypeScript is that TypeScript is going to provide you with types and some other features of a scalable language to get you started with good, predictable typing. That's what TypeScript is all about. TypeScript is a superset of JavaScript, which means that you write your code in TypeScript, it can be compiled to JavaScript, and you should be able to work across with a language that scales and is a lot more predictable, should give you a lot of errors, should allow you intelligence in your tools, etc, etc, etc. The third thing is TypeScript files are modular, which means that if you have a demo.ts, that's supposed to be working as a file module, and if you create a different file called as maybe demo 2.ts, that's a different module altogether. Now this is basically file modularity, and anything that you want to use, you will have to first import that out here, and if you want to use any variable or a function or an object outside this particular file, you have to export it outside. That's something that you will have to remember. So let's quickly look at what is that all about. So in my demo.ts, I'm going to introduce you to something called as import, and the second thing that I'm going to import you introduce you to is called as export. Now these are two syntaxes that's very important. If you notice, there was some IntelliSense there. That IntelliSense is actually coming from my Visual Studio Code editor. Let's not bother about it right now. The two words, technical terms that you need to right now understand is import and export. Now what is import and what is export? Like pure JavaScript, you can actually define a particular variable and say that variable is equal to 1. Now this is a number. Let's do one thing. I'm going to go ahead and put an export here, and I'm going to delete this. I'm going to go to demo2.ts and I'm going to say import from my file demo.ts. ts is assumed to be the TypeScript by default in TypeScript, and I'm going to get my variable from there. There we go, we have imported it. Let's quickly go ahead and do a console out, and I'm going to do a console log of the variable out here, and let's run this particular file. So I'm going to open the terminal yet again, but this time I'm going to say tsc demo.ts. The second is demo2.ts, and let's quickly look at the result. There we go. Now the TypeScript files have actually been compiled or transpiled, that's the right word, transpiled to demo.js, and the demo.js shows you a variable export here, and demo2.js shows you a console log of the variable that has been imported from a particular statement. Now if you notice, there is a require is basically something that comes from Node.js. If you have not read about Node.js, please have a look at the documentation. Require and module.exports is something that is provided, and that's exactly what TypeScript converts and uses import and export in its language. Now we could also have done node demo 2.js, and this actually prints you 1. Remember, Node.js is an environment that lets you run JavaScript in your system. That's exactly what I'm doing right now. Again, if you have not done Node.js, have a look at the documentation. Node.js allows you to run JavaScript files in your system as if it was a server-side language. And as expected, the variable value is 1. It was printed onto the console, and that's exactly what happened. So this is your basics of what is TypeScript. This is the basic of what is file modularity, and we have not touched types. We'll definitely do that, and we also understood that file modularity allows you to import and export. This is something that's really nice in TypeScript, that every file is actually a file module, and it actually converts or transpiles your TypeScript files into JavaScript. That's what it's doing here. So let's quickly get on with some other details, and I'm just going to use the demo.ts out here going forward, or rather let's keep this and we'll work across from this particular file demo2.ts here. Let's also look at declarations, which can be quite helpful, because JavaScript technically is not does not provide you with file modularity as such, and everything in JavaScript can be shared. There is a global namespace, and that particular global namespace is shareable. Now suppose you want to use a global namespace out here, you should be able to go ahead and use something called as declare, and I'm going to say where to, and if the variable where 2 is available in globally, it is going to pull it up and it's going to assign it to the var2 variable. If it's not available, it's going to be undefined. In fact, a lot of cases you will need a lot of scenarios you will need So all right, so let's quickly go ahead and look at some types and how we can use types in our system out here. And this time I'm quickly going to go ahead and get a declaration of a variable called as a string, and I'm going to say string is equal to string out here. I've not used a type as yet, but the way you define a type is use a colon and put the type string. You can use multiple types in Typescript. One is you can go ahead and use number and say number type is equal to 2. You can also go ahead and say boolean is also a type, and you can use a boolean there. You could also go ahead and use an object. The object is not denoted as an object, it's actually denoted as a type any, and you can say it's of a type object. You could also have a function here, you could also have an array here, and you could also go ahead put any specific object like we just did out here. Great, so let's quickly go ahead and do a console log of each one of them and see the results as well in our files. Great, so that was string. Let's print out the number, boolean, and finally let's console out a string. Let me do the same thing, but this time I'm not going to compile demo.ts. I'm just going to transpile is the right word. I'm just going to transpile demo2.ts, and I'm going to say node demo2.js, and this time it actually consoles out everything as is. So notice the colon, notice the type that I have used out there and the way it works. Remember, there is a small difference between a string and a string with a capital S, a number with a capital N, a boolean with a capital B. Now this is very important because all these three would denote that they are objects and not primitive data types. If you want primitive data types, please use the smaller numbers. Remember, TypeScript allows and TypeScript basically understands or it inferences what is going to be the type of that particular string, and it will not throw an error even if you go ahead and not use a type. So which means that if you are using a basic type and the basic type is 2, and you are assigning that particular value to a particular string, the number 2 actually is inferred as an integer. It assigns a number type to string 2. It will not become a string, but the moment you go ahead and apply a string to it, it infers it as a string. So this is something that you will have to remember, very basics of how to work with types here. Great, so let's quickly go ahead and let me create another file here, and let me go ahead say class.ts, and let's go ahead create a class. A class can be defined like in all other languages, can be defined as a class, and I'm going to name the class as maybe test, and there you go. This is a class. This is exactly similar, or this is basically a sugar to your function test, which is written something like this. So it's actually giving an error right now. It's a duplicate identifier. Okay, so let me just change that. That error should go off and should be fine right now. Now, whatever I'm going to do in the class, I'm going to actually replicate that into pure ES5, ES4 syntax so that you understand how it actually works and how it actually gets you running in TypeScript and how you actually work across with classes. Remember, again, classes are just sugar over your function, the way you write your functions. Since you have class, you will initialize it sometime, so there will be a need of a constructor, and yes, there is a constructor in your classes. So constructor is available whenever you go ahead and instantiate a class with the new syntax. It is going to allow you pass variables or pass arguments into it, and you should be able to provide types also out there, and you can do a console log. You can console out that particular argument and get your class running. So if I go ahead and say where t is equal to new test, and I pass an argument called as string saying hello there, and I go ahead and compile, rather transpile class.ts, and I do a node class.js, it should actually say string saying hello there. Great. So we got the constructor working. We were able to work with the class right. Now exactly same thing can be done with pure JavaScript. It's just a very simple change that we are going to do. I'm going to just provide an argument here, and I'm going to do a console dot log of argument, and I'm going to say where tf is equal to new tester, and I'm going to pass the same thing here, but this time I'm going to say it's from a function. There we go. And let's quickly transpile class.ts again. Let's do that, and there you go. You have the same thing working. Let me show that again. You have a function which has a console log, and you are doing a new function, and you're running across your console log inside that. So that's how it basically works. It's almost the same. It's just about a sugar syntax. Let's extend this into variables inside your function, and I'm going to say some where some string where is here, and I can assign a string. I can do the same thing in the function there. I'm going to go ahead and say this dot some string where is equal to string, and I'm going to mention this is coming from a function. And let's quickly go ahead and do a console out of t dot somewhere, and I'll also do that for tf. Let's see what happens when we transpile and run this particular file. Okay, it says that there is a problem. Yes, of course there is a problem. It should have been a semicolon. There you go. So you have your first error, and TypeScript actually caught that and warned you there is an error, I cannot transpile it. So that's something which is very nice of TypeScript. It allows you any kind of error handling that happens while you code, and it's actually detected well in advance, and it warns you that this code will not run, please rectify that, which is quite nice. It actually tells you which line number, which character number, and what is really needed there. It is quite nice because it is very specific for that particular error which was unavailable to you during your development in JavaScript. It's something that you will love going forward. So there you go. You have your details here, and let's quickly go ahead and start differentiating. This, I have not used a type here. The reason I have not used a type is because it's inferred. Now let's not infer it. Let me go ahead and say it's a number, and it actually throws me an error. It says that a number is being assigned with a string, which is not really nice. Please rectify that. So I will have to now force myself to ensure either the type is right or the assignation is right here. You could also go ahead, declare methods into the class, and the method, maybe let's say test method, and I'm quickly going to go ahead and say console log out here and say method triggered. Great. So I'm going to do the same thing for my function. This time I'm just going to say test method is equal to function. I'm going to remove this exactly how it works, and these two are exactly similar. That's the whole goal, to make you understand that it's just a sugar over your function. But the way you write your code out here makes it super easy for you to work with your methods, and it's actually a lot more readable. That's the main goal out here. So let's quickly go ahead and let me actually say t dot test method and run that particular method. I'll go ahead and say test method and run that particular method. Let's transpile this. Okay, let me quickly go ahead and there we go. So we have the method triggered. So this was the basics of classes. And again, classes are just about sugar over your functions, and you should be able to work across with that pretty much well. I'm going to delete this so that we have some space here, and I'm quickly going to introduce you to some more things that's quite nice and beneficial out here. And the first thing is you can provide what is the return type of this particular function. If your function returns something, say for example it returns maybe 1, you can actually go ahead and say it returns a number. If it returns a boolean, you can say it returns a boolean. If it returns a object, you can provide an object, etc. There is something called as an interface in a lot of languages, and that can be really nice, and you can actually work across with interfaces quite well, either to provide a structure to a particular class or to provide a type to a particular object, etc. So let's quickly look at that. But before doing that, let's also understand that there can be something called as access modifiers, which I'm definitely missing out here. Access modifiers tell you whether you can access a particular variable from outside of that particular function. So say for example, if I go ahead and make private the variable sum string variable, I will not be able to access that in my object. So if you notice, this time only the test method is being shown because that's supposed to be available. You could also go ahead and make it protected. Protected will have protected access, but again it is going to not allow you to use that. If you extend a particular class, you should be able to go ahead and use that quite nicely. And let's go ahead with maybe a tester here. I'm going to introduce you to a new concept of oops in TypeScript, and I'm going to say it extends test. And this time I'm not going to instantiate a test, but I'm going to instantiate tester, and I'm going to create a constructor In my constructor, the only thing I have to take care is my constructor needs, if you notice the error that it says is it needs super to be instantiated. So I'm going to instantiate my super class, which is supposed to be the test, and I will pass a string here which is needed. Remember, I'm not providing types here, so let me also provide type and say stay clean. I'm going to pass this to super. I don't need to reassign the type there, and there we go. Let's go ahead and transpile it again. I'm going to say tsc class.ts, and let's also go ahead and do a node class.js. So there you go, it did actually go ahead and print your console log argument. You could also access t dot test method, because test method is available in the parent test, so it should be accessible from there. Remember, protected is not accessible. Let me go ahead and make this public. Now there you go, you should have that particular variable also accessible from there. So access modifiers are available with classes, and you should be able to work across with these access modifiers quite well, as you do in any other language. So let's quickly go ahead and delete this, and I'm going to introduce you to interfaces quickly. That should wrap up the basic usage of TypeScript, and you should be able to work across with that quite nicely to extend your skills and working with TypeScript. Interface is nothing but a structure that you provide for a particular class, function, variable, so that you are able to ensure that a particular object is of a particular type. Remember, class is also an object, function is also an object. A string with a capital S can also be an object. You can basically do new string, new number, new boolean in JavaScript. That's an object. But a data type is with a small s, which basically denotes that it's a variable which has been assigned a particular number. So interfaces can be defined very easily, and the way you define an interface is using a keyword called as interface tester. And I'm going to go ahead and say I need to have a method called as test method in this interface, which is of the type any, which means that it can be a function, object, array, it can be a number, string, anything. I could now go ahead and say my class implements tester, and it will not throw an error. But say for example I go ahead and say test methods, and this time it says there is no implementation of the interface tester, and it needs a property called as test methods, which is missing, which is definitely true, which is missing. And now if I go ahead and change this to test methods, that error actually goes off. So basic error handling is very strong with TypeScript, and it allows you to manage this quite well. The second thing is, always remember there is no private in case of interfaces. All your interfaces have to be of the type access modifier public. It's assumed to be public, and the moment you go ahead and make it private, you will notice that it says that it has not been implemented correctly in your class test. So that's something that you will have to remember. All your interfaces define a public access modifier and a structure to your class, or could also mean that you can have an object of the type tester, but it should have it should be assigned with an object that has a method called as test methods, and this is an absolute legal implementation of TypeScript. This is absolutely fine, because in case of JavaScript, uh, everything is an object, and in this particular case, your class test is also an object which has properties, some string, test methods. Similarly, an object has properties with it, and that property in this particular case is test methods. So you will be able to use interface as a type, or you can also use interface to create a structure for a particular class, useful in a lot of places to ensure that your class method implementation is right and you have basic or very important functions implemented compulsorily if you really want to get your application up and running. So that's something very nice about interfaces. Remember, interface can be used to provide structure, or they can be used as types and can be applied to variables as well. Not necessarily it has to be applied only to a class, or it has to be applied only to a return value of a particular function. It's absolutely not necessary. We have to use this. I'm really so sorry. So this dot string is of the type tester, and we are returning that. That's the reason it's not throwing up an error, because test methods is now returning a return value of this dot string, which is of the type tester. So there we go. That's something that we already missed. So let's talk about this for a moment's time, and you should be able to refer any scope of this particular class within your functions, within your constructors, with this syntax which is scope within this particular class, like in case of JavaScript, and you should be able to reassign values to it as well. Or you can also trigger out these using this dot test methods, and since test methods is actually a function returning something, I will actually use some where to assign it, and it should be scoped within the constructor, and in this particular case for somewhere, because we have used let. There you go. So let's quickly look at one last thing that I would want to cover before we go ahead, and that is I'll create a class called as testing, which extends test, and I'm going to create a constructor. Remember, we talked about the super. Let me also instantiate the super here, and I'll pass a manual value here, and I am going to create a variable, and this particular variable I'm going to say it's of the type tester, and I'm going to put a access modifier here, and the access modifier is supposed to be protected. Let's quickly go ahead and remove this let, and I'm going to say this dot. Now if you notice, we actually have some var out here because it's protected. Remember, the protected values are available within the extended classes but are not available on the objects outside. I will show you what I'm trying to say, and there you go. If you notice, some var variable is not available outside. So that's exactly what you should be remembering of when you're using access modifiers, especially when you're working with protected objects, variables, functions within a particular class. So that's something very nice about TypeScript. Great. Let me just rectify these small errors. That's actually happening because of this variable out here. This doesn't need an argument. That should get resolved. There you go. So we talked about classes, we talked about constructors, we talked about variable declaration, function declaration within classes, we talked about extending classes. We also talked about super when we are extending classes, along with which we looked at interfaces and extending classes with interfaces, and using interfaces as types. So that's kind of quite nice, and that covers TypeScript in a jiffy in terms of types and usage of classes. We'll also look at arrays as well as enums in the next few minutes, and we will wrap up TypeScript in this particular video. Let's create a different file for advanced types, and let's look at enums and arrays in a little detail. So I'm going to create a different file for this very specifically, and I'm going to say where string is equal to test. Now this is a string data type assigned to the variables str, and we should be able to console it out without any issues like we did before. So let's also do a transpilation, and let's do a node advanced types, and there we go. We have that test printed out here, which is fantastic. In case you're working with arrays, there is a small difference in the way you work. Any is the type that you use for arrays technically, but you can also go very specific about what types are assigned to an array, and what if you have a mixture of numbers, booleans, and different objects within an array, you can also work across with that. I'm going to make a small change. I'm going to add an array symbol out here to the type string out here, and I'm going to delete this, and I'm going to make this as an array, and I'm going to apply strings out here specifically. Great, so we have created an array of strings, which is fantastic. Let me try and change this to a number, and let's see what happens. It actually says that it is not assignable to the type string, because 2 is not a string, it's actually a number. I will have to force myself to work with strings very specifically. You can do that for numbers as well, and you can say that a number array is going to have a list of numbers associated with it. Similarly, you can also have a boolean, which can take boolean values, and I'm missing. Great, so we have a boolean here. In case you want to have an object within it, you can actually go ahead and assign objects to it, and you can say it's of the type any, and you can go ahead create an array of maybe an object, maybe a number, maybe a string, or maybe a boolean. It can take anything. This is a mixed array as well as an array which can take care of objects as well. So this is the minor difference between your types that are being assigned as a simple string, number, boolean, any, and in case of arrays, you can actually go specialized. You can work with arrays directly with these array types out here, which is very specific for array items only. I'm going to go ahead, do the same thing. I'm going to transpile this particular file again, and I'm going to run this particular file again with a lot of other consoles as well. So let's do that, and let's look at the result. I did not add this, so I will have to retranspile this, and I'm going to retranspile and run this particular file again. So let's retranspile this. If there are errors, it's actually going to show that in the console, and now I'm going to run this particular file. Great, so we actually have the result of these consoles coming out here, which is fantastic. Alright, so let's quickly look at enums as well. Enums is not an advanced type, it's actually an advanced usage like in all other languages. I'm quickly going to create an enum called as a, and I'm going to say test is equal to 1, and maybe I'll also say where is equal to a string, maybe str. And the way you use an enum is I will go ahead and do a console out here, and I will say a dot test. That's how you reference uh, enum here, and I will console out this particular value out here. I'll just delete this for the sake of space here, and let's open up the terminal. Like always, let's do a tsc of types.ts, and let's do a node. There you go. So we have that particular variable value or that enum case printed out here. There is also another small usage where you will be able to work around with enums quite well, and let me also show that to you. Let me say a variable let b is equal to a dot test, and if you want to actually get the key, let me do a console out of b of a of b. Now what we are doing is we are actually referencing the enum value b, and we are getting the key value of a here. Let's again do a transpilation, and let's quickly go ahead and run this. We'll actually get the key of that in the console. So we have an option to get the references for the key as well as the value, or the key value of that particular enum case in this particular section. So that was a quick introduction to enums, and in the next few minutes we'll also look at how we can work around with some advanced types that consider classes, or maybe for a matter an object as a type as well. So that is also possible. So let's look at it right now. Let's see object definition directly into the types. Instead of creating an interface, I can go ahead and say where C is of the type maybe a key of test and a value that is of the type string, and let me now go ahead and define test, and I'll assign a value of string there. So it allows me to use the type directly out here. That's not generally good, but you can also do that. Let me just change this to tester, and the moment you change this to tester, it says it's not assignable. So this option of directly assigning types with a particular object without creating an interface is possible. Try and avoid it as much as possible in your code, because you will not be able to reuse this kind of a definition in your files or in your code. That's something that you might want to know as well.
Finally, let's look at namespace as well in a quick simple format, and this time I'm going to just make small changes to the names so that we are using names that can be referenced nicely instead of having a data type reference here. And I'm going to say namespace test is going to include all these variables. I have to export these variables so that they can be used in a different file, and let me export all of these. The moment I do that, you will notice that this is now included within the namespace. You should also be able to reference it with the namespace.num, namespace.bool, namespace.obj, etc. within that particular file. And if you want to go ahead and get that in a different file or reference a particular namespace in a different file, you can just go ahead and put a comment with a // and then use a reference with the path of the reference file name, and I'm going to say demo2.ts, and I'm going to close the reference path, And finally, I can go ahead and say console log of maybe num or whatever. That should absolutely be okay. It will automatically reference that particular namespace and get you that within your particular file. So that's how you use a namespace within your particular files and work across with namespacing of a particular set of objects in your list of files in your application. So great. So that was basics of all your reference points, all your declarations of types and declarations of interfaces, enums, superficially, and this should sum up what is all there in TypeScript. Definitely have missed some particular sections, and if you want to know more about this, please do ask questions. I'm creating a module, tutorial training course for TypeScript, which details TypeScript in every aspect of it. If you want to change the way in which I am explaining this, or if you want to change some particular contents of it, or if you have a suggestion of bettering this, please do leave a comment. I'll be absolutely happy to make those changes in the course material or include those sections in the course material as well. Your feedbacks are welcome. Please do provide the feedback, and if you like this particular video, please like and share this particular video as much as possible. Thank you very much from Gary here again. You all have a nice day and happy coding.